Hello everyone, welcome to this class. In this class, we're going to solve for division and multiplication of logarithm. So what we're going to do is to solve numbers, division and multiplication using our logarithm table. So we have example 13 here. We're being told to evaluate 34.83 multiplied by 5.427. There's something I want us to know. These are our law of indices. It says that a number raised to power x multiplied by another number raised to power y. I can call this 10, I can call it any number. It's the same as that number, the power, adding both the power, as we have already done before. So now this 34.83. First, I will explain it using this law of indices so you understand why we do what some things we do. We find the logarithm of 34.83. First, we find the characteristics. 34.83. So this is the same as 3.4 times. Okay, I forgot 8. 3 times 10 raised to power what? 1. So our characteristics here is 1. So we'll go to 34 under 8 difference 3. So this is our logarithm table. This is 34 under 8, 54, 16. So I'll write it out. 54, 16. So difference 3, the last one, that's 4. So add 4 to it. So my final answer will be 54, 20. So my logarithm log 34.83 is now what? Characteristics dot 542. Go for the second one. Log 5.427. When we find the characteristics, if we convert it to standard form, to say we have 5.427 times 10 raised to power 10. So my characteristics in this case is 0. So I'll look for 54 under 2 difference 7. So using my logarithm table, 54 under 2. This is 54 under 2. Now notice I'm getting 7240, and I notice that the answer is different. So I now look around. I'm seeing that here is 73, here is 73, here is 73. So how come here is 72? So from there I can sense that there's an error here. What I did, remember I told you that this logarithm table is at the back of your textbook. So I checked the one at the back of this textbook. This is 54 under 2. Let me raise it up so we can find. Okay, I can't. This is 54 under 2. This is 2 here. You can see this is 734. This is 7340, but here you are seeing 7240. So obviously there is an error here. For those of us using the formula table, this is 7340, not 7240. So I'm using 7. I'll write down 7340. So the difference is 7. So I'll go to difference 7. 54. This is 7 down. That is 6. So I'll add 6 here. So the answer is 7346. So my logarithm will be equal to the characteristic 0.7346. Hope you are following up. For those of us that ask, how do I know the answer? Some of these is once you're solving it, always try to cross check and use your calculator. You can use your answer column of your textbook, because anything human being does, there is prone to be error, no matter how little it is. So now I've gotten the second answer. So what's the next thing I'm going to do when you are solving for multiplication using logarithm? First, find the logarithm of this, find the logarithm of that. So I've gotten them. Remember what we said about logarithm? We said that this value you are getting simply means that 10 raised to power this value will give you that, and 10 raised to power this value will give you that. So you can rewrite this equation as, now we are trying to prove why multiplication is we are going to add the logarithm. That's why I'm going through this long process. You can divide this, you can just say that this equation, this 34.83 times 5.427 is the same as 10 raised to power 1.542 times 10 raised to power 0.7346. Remember our law of indices. When you have this kind of thing, it simply means you add the power. So it will be 10 raised to power 1.542 plus 0.7346. So when you add these two values, what are you going to get? You are going to get 10 raised to power 2.2766. Are we together? So if you solve this is the same as saying antilogarithm of 2.2766. So we are trying to explain this using indices. But going forward, we just go straight and solve our answer. If you solve this using this whole expression here is the same as looking for antilogarithm of that, because logarithm simply means this is logarithm. This logarithm, when you have a number, you're being told to find the logarithm, you simply say what number will you raise 10 to give you that number. Then antilogarithm simply means when you raise 10 to a number, what are you going to get? So we'll look for antilogarithm of this. So we'll go to our antilogarithm table. So we are going to first bring out the number we're looking for the antilogarithm. We have 2.2766. Remember, in our antilogarithm, you leave the characteristics and solve the dot. That's the mantissa. So you look for dot 27. This is my antilogarithm table. This is my dot 27 under 6. I'll go to under 6 is 1888. So I'll write it out. 1888. Difference of 6. 27 under 6. Difference of 6. 3. So I'll add 3 to it to give me 1889. So this is what I get. Then how do you now get? You now have to factor in the characteristics. Remember I told you can get the characteristics. Let me just put this like it will now be 1.889 times 10 raised to power what? The characteristics. We should give you 188.9. is now a standard form. This is your final answer. I hope you're getting it. Let me explain what we did. First, you have a number and you convert it to your logarithm. This is the logarithm of this and this logarithm of that. And you remember that logarithm of number simply means when you raise 10 to that number, what number will you raise 10 to give you the number you are looking for the logarithm? So I now express it in that form. This is this and that is that. And then using our law of indices, we simply know that if we are to solve this kind of math, we are just going to add the power. And when we add the power, we'll now look for the antilogarithm, because this, to evaluate this number, simply means find the antilogarithm of this power here. And this is what we did. We now get 1889. So this is just the long process of proving this. So if we were to confirm if what we did is correct, you just simply do this. Use your calculator and punch 3483 times 5.427. So let's do that and know if we are getting the same answer. So from my calculator, I'm getting 189.02. So you can see that the answers are very, very close. If you round off this to a whole number, you are getting 189. This one, if you round it off to a whole number, you're still getting 189. So that proves our first law of logarithm in base 10. So going forward, I'm going to solve it and go straight to the answer. So let's prove for the division. This is example 14. We have 4562 divided by 98.76. So first we change this to logarithm. So log 4562, right? First we change to standard form, which should give me 4.562 times 10 raised to the power 3. So my characteristics is 3. Now let me solve for the mantissa. We have 45 under 6 difference 2. So this is my logarithm table. I go to 45 under 2, that's 6542. Bring it out. 6542 difference 2. 45 under 6. 45 under 6. I think I made a mistake. It's supposed to be under 6, which is 6590. So I'm not using this. 6590. 45 under 6. So difference of 2. Go to the difference side. This is 2, which is 2. So I'll add 2 to it. I have 6592. So go to the second one. Look for the logarithm of this. And this is 45. So log of 98.76. First you convert to standard form, which is 98. Okay, it will be 9.876 times 10 raised to the power 1. So your characteristics in this case is 1. So we now look for the logarithm of 98 under 7 difference 6. This is 98 under 7. This is my 7. 9943. So I write it out. 9943 difference 6. This is 98. Go to difference 6. This is my 6 here. 3. So add 3 to it. 9946. Right? I think I didn't finish up this one. This one will now be the logarithm of this one will now be the characteristics dot the mantissa 6592. While the logarithm of this one will be the characteristics and the mantissa 1, which is characteristics 9946. Hope you are together. The next thing we are going to check is, remember that this logarithm, as we proved in the previous example 13, simply means 10 raised to power this 10 raised to power that, which is 3.6592 divided by 10 raised to power that 1.9946. Excuse me. According to our law of indices, this will simply give me 10 raised to power 3.65 excuse me 6592 minus 1.9946 according to the law of indices. So this will be, if you subtract this, you have 10 raised to power 1.6646. So solving for this, I'm still repeating myself, we are just proving this law. Solving for this simply means looking for antilogarithm of that. As I said earlier, log of this means which number will you raise 10 to give you this. So that is 10 raised to power this is that. Log of that also means which number will raise 10 to give you this. So antilogarithm means when you solve 10 raised to power that power actually. So to get what we have here, we just simply find the antilogarithm of this number on top. So I'm just going to find the anti-log of 1.6646. And how do we solve our antilogarithm? We leave the characteristics out, solve the mantissa. So here will be 66 under 4 difference 6. So we'll go to our antilogarithm table. This is our antilogarithm table. Always make sure you are checking the table to confirm. So I have 66 under 4 difference 6. So this is 66 under 4. This is 4 here. 4613. So So I'll write it out. 4613. Difference of 6 is what? 6. So I'll add 6 to it. So we have 4619. So to finally get the final answer, we simply remember what I taught you. This is the characteristics. You now do something like 4.619 times 10 raised to the power 1, the characteristics, which is the same as 46.19. This is your final answer. So the first thing you will now do is to confirm if this answer is actually correct by using your calculator to do something like, let me say, using calculator. We'll now solve for 4562 divided by 98.76. So when you punch this in your calculator, what do you get? So for a calculator, you have 4619 approximately. So you are getting exactly the same thing. So this proves our division and multiplication law of logarithm. So let me explain properly what we mean. When you are given a number x and y, and you are being told to look for x times y. So what you are going to just simply do is convert x to log, convert y to log, then add log x and log y. Whatever you get, look for the antilog of that antilog. The same way, if you are given x and y and you are being told to look for x divided by y, simply look for log x and look for log y. Subtract log x from subtract log y from log x and look for the what? Anti-log. So let's just solve example. Here we have to go through this long process just to prove it using our law of indivisible. Now you don't need to go through those long process. Simply do this explanation here. Let's solve an example. Then you can always confirm your answer with calculator as we did in our previous example. Here is exercise 1J number 17. So we are given 286.3 divided by 17.08. So simply convert this 286 to log. So log 286.3. First, change this to standard form. You will get 2.863 times 10 raised to the power 2. We have a class on standard form. You can check it in our standard form class under this channel playlist. So we now look for the logarithm of 28 under 6 difference 3. So this is anti-logarithm table. So as you can see, I'm checking it to make sure I'm not making that mistake. I'll go to logarithm of number 28 under 3, 4518. Okay, under 6, forgive me, 28 under 6, 4564, 4564. Difference of what? 3. 28 under 6. Difference of 3. That is 5. So you have 4, 5, 6, 9. So this is your mantissa. So your final logarithm will now be the characteristics dot the mantissa 4, 5, 6, 9. This is the logarithm of the first one. Then we'll now go for the second one, logarithm of log 17.08. So changing to standard form, I'll have 1.7 0.08 times 10 raised to the power 1. So my characteristic, okay, I didn't write this out. Characteristics here is 2. So my characteristics here will be what? 1. So I'll look for the mantissa, which is 17 under 0 difference 8. So 17 under 0, which is my 17 under 0, which is 230804. Hope you are seeing it. 17 under 0, 2304. 2304 difference 8. I will now go straight to the different side of it. 8 is 20. Now add 20 to it. Have 23 to 4. So my logarithm will now be the characteristics dot the mantissa. Right? So next thing I'm going to do is to add, check, okay, this is division, so we are subtracting. It will be this minus that, so it will be 2.4569 minus 1.2324. My answer will be what? So my answer will be 1.2245. So this is my answer. So the next I'm going to do is to look for the anti-logarithm. Let's check the table. I said this is the division side. Look for the log of x, look for the log of y, subtract log of y from log of x, then look for the anti-logarithm. So we've already find out our logarithm of x, logarithm of y. Now we are subtracting it, and this is what we get because it's division. This is our division side. So now let's look for the anti-logarithm of this. So next thing we are going to do is anti-log of 1.2245. So the characteristics is 1, so we don't deal with it, we just deal with dot 2245. Now make sure you are in the anti-logarithm side. This is an anti-logarithm, so 22 under 4 difference 5. 22 under 4, 1675. I'll now write it as 1675. Difference of 5. So I'll go to the different side of it. This is my 5, which is 2. So I'll now add it. I will have 16. Okay, so I'm having some issue writing this. Oh, this is 1677. So to get the answer, I'll just do 1.67. Oh, I'm having issue writing this. 1.677 times 10 raised to the power of what? The characteristic. This is the characteristics 1, which will give me 16.77 as my answer. Let me just write it here, answer. So the next thing we are going to do is to confirm if this answer is correct by using our calculator to solve for 286.3 divided by that. So let me check my calculator. So from my calculator, I'm getting something like, let me write it here. Calculator, I got 16.76. This is what I got. So this is 16.76, and from using the logarithm form, I'm having 16.77. So the answers are very close, meaning that we are correct. So let's solve for multiplication. So this exercise 1J, number 18. So here we have for multiplication. Remember what we say: find the log of this, find the log of that, add the two logarithms, and find the anti-logarithm of your answer. So first, let me write it out here. Log x plus log y, anti-log. So log x is what? First, let's say log 34.07. So we have change it to standard form. You have 3.407 times 10 raised to power 1. So my characteristics is 1. So I'll look for 34 under 0 difference 7. Mind you, this is anti-logarithm table, so go to logarithm table. 34 under 0 is 5315. 5315. Difference of 7. Good. Which is 9. So you add it. You have 4 here, 2 here, 3 here, and 5. So your logarithm is characteristics dot the mantissa 1.5324. So look for the logarithm of the second one, which is log 1.007. So changing to standard form, we have 1.007 times 10 raised to power 0. So look for 10 under 0 in our logarithm table. Here our characteristics here is 0. So look for 10. This is our 10 under 0, which is 0, 0, 0, 0, 0. Different 10 under 0, difference of 7, 29. So I will now have 29. Oh, sorry, I forgot to write out the first stuff. First one is 10 under 0, which is 0, 0, 0. I'll write it as 0, 0, 0, 0. So difference of 7, which is 29, if I'm not wrong. Yeah. So I now add it. And I have 0, 0, 2, 9. I know this kind of thing can be dicey. So let's put dots here. So the characteristics is now 0.002. Sorry, the logarithm is 0.0029. Mind you, this mantissa is just 4 decimal places. So you know, things like this will open our eye to things, to this kind of explanation. So this is what you get. Some people might make mistake of assuming that this is 29. If you have done that, you would have failed it. At the end of the day, your answer will be 0.29. So these are kind of things we should watch out. We should watch out for. So this is the logarithm of the second one. So the next thing is to add both logarithms. You now have 1.5324 plus 0.0029. So you have 1.5353. So you look for the antilogarithm of this. And when you're looking for the antilogarithm, don't forget the characteristics, you leave it, you look for the mantissa. So I'll look for dot 5353. So I'll look for 53 under 5. This is logarithm. Always pay attention. I know I'm leaving it. I'm doing this so that you'll get used to it. 53 under 5, which is 3428. 3428. Difference of 3. 53 under 5. Difference of 3, which is 2. So when you add it, you have 3430. So you're now bringing your characteristics. Simply means that 3.43 times 10 raised to power what? The characteristics 1. So your final answer is 34.3. So the next thing we are going to do is solve this using our calculator to know if we are getting close to what we have here. So if I use my calculator to solve this, let's look for the answer we get. So from the calculator, if what you get is 34.308, but leaving this in 1 decimal place, this is what we have. So you can see that our answer are exactly the same, so we are correct. So this is how to solve for your logarithm using the table. Remember, this is logarithm with table. Mostly you solve this kind of thing when you have theoretical exam, when you want to show your workings. On a norm, you just punch your calculator and get your answer. So simply, when you have for, let me summarize it again. When you have for multiplication, simply change it both number to logarithm, add both number, look for the anti-log, and that is your answer. When you have for division, simply change both number to logarithm form, subtract, and look for your antilogarithm. Thank you, and see you in the next class. If you have any question, do it to drop it in the comment section.